Hi, Sachin.
Hey,
Hello.
hey.
Hello.
Hello.
Hi. Still waiting for Pascal. Let me just check if he comes.
He hasn't added himself to the agenda yet.
Yeah, but I talked to him, so he wanted to. Give him 2 minutes. Come in.
Hello.
And no, you're not in the
Hello.
meeting. You're actually not in the meeting.
Oh, but there's a pull request.
Let's see. No. There's Pascal.
Oh, I started comparing. Sorry.
Pascal, you're not in the meeting.
I'm not allowed to talk. Sorry, guys. It hurts to say, but I completely forgot you. Who are you again?
Okay, come on. I trust you. Okay. See, Kamil is in. Okay, let's start. Hi, everyone. Let me remind you that by being here, we all agree to the GraphQL Spec Membership Agreement, the Participation Guideline, the Contribution Guide, and the Code of Conduct. All published or all linked into our agenda. Also, let me remind you that these meetings are recorded and published on YouTube, and we may or may not use LLMs for summaries and whatnot. We're actually doing it. So just if you're not okay with that, then you have to sign off. Okay. With this said, let's start with a quick round of introductions. My name is Michael.
I'm Martin from Apollo.
I'm Benjamin from GraphBase.
I'm Sachin from Apollo.
Camille from the guild.
Pascal from Chili King.
Awesome.
I'm Ducky from Apollo.
Sorry, didn't see you. Also,
Edit.
awesome. Okay. Oh, good. This will merge eventually. So we went over a couple of issues and created a more curated list of things that we should have a look or discussion on and then decide what to do with it. I think there are 4 more left after that. And then we basically have all open things discussed and decided on. Let's actually start with this one. We had at some point discussed that, and there was general agreement on that. But
I don't remember that, but maybe I wasn't part of that meeting.
Yes, you were.
Was I?
Yeah. We discussed like that external. We discussed back then that external actually is the wrong name for it, and that also in Apollo you had other thoughts on that at some point.
But I'm wondering how partial would fit with the use
with requires? Because that doesn't seem to fit the word partial.
For requires, you don't need external.
You do, yeah. Right?
You don't. You don't.
At least that was the original design. I don't know if that has
Yeah,
changed.
yeah, yeah. That's exactly what the discussion was around, because like in the design that we have now, you have only one use case left for external, right? Because with requires, you actually have these things as arguments, so you don't need to
Oh, yep,
expose
no,
them anymore.
that makes sense. Yeah. So requires plural,
Yeah.
like the current, that does require external,
Yeah,
but
yeah, yeah, yeah.
require in the current system doesn't. That makes sense.
Yeah.
There's
Yeah, and
too many required in that sentence, Martin.
sorry. Yeah, so this doesn't require the re-exposure of things anymore.
But isn't it the same
And
problem? Like of being sure that dimension is what you expect when you compose?
You don't need it because you have the type. So
you have everything here.
Oh, okay, okay, I see.
the
Okay,
difference is you have all of the information that you need for it to map. And also when you have complex requirement like below with the dimensions, this would be horrible when you have to re-expose it again on the
Yeah,
type
yeah.
just for fun, you know?
okay,
Yeah.
okay.
Yeah. And
Thanks.
maybe for background, like the original, the reason we came up with external is by analogy with like extern declarations in C. So the idea was that you would sort of define the fact that a field has a certain type, even though the implementation isn't part of this particular subgraph.
Yes. Yes, but yes. And but now that I think the discussion now that we only have a reason for it in provides, it's actually partial. We don't have to use that name, so that was just what I found in the notes that we had. The idea was like in this case, was it it was partial. We kind of describe when something is there. So if you come, for instance, through users here, email will be there. And that's why it's marked here as external at the moment. If you come through other passes in this subgraph, you will maybe meet an empty email field, which is expected, right? It's only valid if you follow the provides passes.
Yeah.
But external in this combination, if it's only used with provides, is kind of not the best name.
That makes sense. Yeah.
There maybe is one other question. So in Apollo, I think external is used for at least four different things. One of them was
Yeah.
required, one was provides, another was context. There's also one other case with interfaces, where suppose you have two implementing types A and B, some object types, and an interface type C. And suppose we're just all considering some field foo on all three of those. So if some subgraph A declares type A with a field foo, and then B declares subgraph B with a field foo, but not vice versa, who would declare the interface C with foo is the problem. And so in that case, we also use them to indicate that an implementing field doesn't really exist in the subgraph.
An implementing field doesn't really exist.
So A has to implement C in one of those subgraphs, right? Is the thing.
Yeah.
And
Yeah.
the thing is, and B has to implement C.
Open quickly.
Just to visualize for everyone. So we have interface A.
Or,
Yeah,
but
sure.
I think it was C.
Yeah, interface A, whatever's fine
Yeah.
there. So let's suppose we have some interface A, and then we have some field we care about A, and that's fine. And suppose we have two object types, B and C, each distributed amongst the subgraph. So B is in subgraph 1 and C is in subgraph 2 and whatnot. And so sorry. In that case, sorry, maybe interface A should have two fields. I think I misspoke.
Ah.
Let's say that there's two fields. Let's say B type. Let me just say they're B and C. Let's say.
A and B or B and C?
A and B works fine too. So, yeah, sorry, I misspoke. So, in this case, what you have is like you have, let's say, basically B implements some of those fields, but not the others. And the same holds for C, I think. Maybe that's what it was. There's a case where you can't have A be implemented in both subgraphs exactly because one does one field and not the other. It was
But
something
isn't
like
isn't the idea that each subgraph would contain like only the subset of fields that it
Exactly.
implements in the interface, Steph?
that's right. That's right.
No,
That's
but also in the interface, like they both need an implementation of interface A, right? Or they both need interface A, like a definition of interface A in their subgraph. And isn't the idea that they would
it
each
merges
have
them.
a different subset of fields there?
Yeah, that's what was how I was thinking.
Yeah, but I think there was something that was there's an edge case I think that we have in Federation where we actually do allow you to have like a object field be declared external sometimes when it implements a field that isn't external, I think. But I don't remember what the specific case was around that off the top of my head. I
It
think
would be interesting to understand what the reasoning was behind it.
Could this be related to a requirement? So that you can, in this subgraph, require B, even though that you haven't defined it in this subgraph? That you can actually say that B is external?
I
It
know
might-
what we're meaning, like what Pascal maybe.
Like when you want to define a requirement here on B. Well, in
Yeah. Sorry.
yeah.
Is it here? And this external. No, C is there. How do
So
you
it
add
would be,
requires? Requires. Sorry. I'm
yes.
so used to.
Oh, sorry. I think I remember the original use case now, and I think I was closer the first time. Sorry. My bad. Okay. I'm remembering it now. There was one there, but it was just one field. It was just one field. So suppose we just have let's say you can put a dummy field there if you want, just so that it but it's suppose let's consider the case A, right? So both subgraphs implement both A and B, or both the implementing types, in this case B and C, sorry. So like suppose subgraph 2 implements B and C, and then
Like this?
yeah, so suppose both C implement A and then B implement A. And then in this case, like subgraph 1 does not introduce A, and then subgraph 2 does not introduce
Yeah, but then why have the field there in the first place?
sorry, so okay, let me rephrase this. So in subgraph 1, put type C implements A.
In subgraph 1,
Yeah, you
we
just put down a type C there, and
it's done. Okay.
so both of them implement B and C, and
I
then
see.
yeah. Yeah. In that case, let's suppose A is gone in one of them and A is gone in the other one in the other subgraph.
Right. So the thing is that type C, okay, I understand. Type
There.
C doesn't have the data for B. So you mark this as at external.
But yeah, but you
That's
just need
what
to
it was.
satisfy the
Exactly.
validation of implements A. Yeah.
The
That's
interface.
what it was. That's right. Okay, now I was closer the first time, but then I lost it.
It has this
It has
on
only the data for A. It doesn't have the data for B, but to satisfy the interface, you actually have to define it as external so that the gateway knows that from this subgraph it can never resolve B.
Yeah. Oh, I think I know a good name that fits both use cases. Maybe
Go
not.
ahead. Maybe not.
Yeah.
Maybe.
Well,
I may or may not have this data.
so subgraph 2 in this case also needs the declaration of B. And in that case, that one will provide C's B, but it won't provide B's B.
Yeah.
But
We
yeah,
have too many bees. And
I do now like in subgraph 2 we could now just have this, right? But as we have some partial data here and we only want to serve some partial data from here, we are now
yeah,
required to have this.
yeah. And partial is a bit weird here because it's not
Yeah.
necessarily partial because it's never serving that field. So
Exactly.
we need another name.
Yeah.
Can you
But this case, let me save that.
Yeah. Can you post? Don't save it. Put it in an issue so everyone can see it.
Yeah, I post, but I need to have it saved so it's not gone. So this is super good that because we have to also make sure that this case works with the specification as also with satisfiability and stuff that we have so far.
Well, it would just work because
Would it?
External isn't taken into account with satisfiability. That's the whole
That's right.
point. Yeah.
Yeah,
we
this is more about
we ignore all external fields in satisfiability.
No, we ignore provides and external.
Well,
Yes.
both.
Yes. You're right. We ignore provides and external. So,
but this would actually be a problem because you don't. Yeah, you just should never, like, this should be a note in the validation and planning section. Never plan on interfaces. Always plan on objects. Like if you have a path in, like Sachin, what we discussed, with the whole, like a few months back about the satisfiability, always objects, never abstract types.
you mean always type explode in the satisfiability?
You have to.
Yeah.
Yeah,
Okay.
yeah.
Don't have the information on the interface. Like
Yeah.
you
Oh
could
yes,
plan.
because we don't know.
Yeah, satisfiability basically assumes that you can properly do type explosion during query planning, and given that, it can always choose to type explode when it's exploring paths. Is basically just so as long
Yeah,
as
and in query planning you
type
can
explosion.
actually check if one of the implementations has external on it.
Yeah.
Then you must type explode.
Yeah, type explode. Like this is not ideal, but it's fine.
It's definitely not ideal from a complexity
Yeah, it
point of
depends
view.
always.
But
If
yeah.
you just have 2 implementation, it doesn't matter. If you have 100 implementations, like if you type explode on Node, then it's a problem. But yeah.
Yep.
Yeah.
Yeah.
But this is really good.
That's a case
Okay.
I didn't think about before. That's good.
Yes, and so I will update the external directive and also describe this use case. But this was use case 1, you said. 1 of 4, right?
Yeah, yeah. So provides and context kind of do the same thing with it. So if we're going to like not use it for provides, we probably also wouldn't use it for any analog of that context, assuming that eventually gets there. And the last case was provides, I think. So I think the other two basically are the other cases are covered. It was just this one that wasn't covered, I think, and that's
Okay.
why it's up here.
But just why do you need it in context?
Oh, so in context, you can also refer to fields that are not in that subgraph. And so similar to requires currently, we have people potentially write those types down, and then that's
Okay, but
you know.
I
It's also a
think
way
this-
of passing through information that you don't
Yeah.
provide yourself. Yeah.
Yeah,
Yeah.
but we wouldn't actually have that, or
That
because
depends.
with requires we can do stuff.
It depends, Michael. It really depends how we do the context.
Yeah, but
In
if we
context,
had the
it could be
context,
that it could be that in the context we don't have the handy type information that we have in the requires case. Like if you just have in context, if you just write foo, you have no idea what the type of foo is. In require, you know what the type of foo is because you have the.
but it depends. You always look at. We don't have to discuss on that, but if you, for instance, store something in the context from a path, you always look at all of this by looking at paths, right? If in your path above you is something that was being put into the context, you have the type information. at least in the query planning. So it would be it would be something that you would need to validate on satisfiability rather than validation.
Yeah, and we could also use what we discussed internally
But yeah,
about type. Well, it's a bit in a different context.
yeah, it's let's have a look at that when we solve all the basic stuff.
It would be so what we discussed internally is that we could extend the selection map syntax to allow when you have an object type, you can pass a generic. Actually, that should already be allowed. So,
That's already.
yeah, so that you can pass the leaf type as well. But that's
But anyway, okay, I will put this. Okay, I will update external. Do we want to go with external, or is there something better, or will we just stick with it? Like partial doesn't fit.
I think external fits this use case, and it fits like the old requires. It doesn't really fit provides. That has always been a weird use of it, but we already had it, so it made sense. But
yeah, we could also. I mean, yeah, we can always think about it. We don't have to decide it today. We can move that to next week, and we could also say this is prior art. We don't want to make too much a fuss for this, as it's not only the provides case. I was only thinking the provides case, and for that it felt
So
not right.
there's one other thing here that's a little off, maybe from an example I had in my head, and I realized that the difference actually does make a difference. So in this case that you've written, you could always remove implements A from the line 12, and then technically 22 has it, and then it gets put out into the supergraph schema, right? Is one thing to sort of know. Like I think in Federation, I think it only at the moment mandates that one of your things has the implements for the implements to propagate up to the supergraph.
Yeah. So you say you could remove this, or
Well, no, sorry.
no, line 12. Well, the old
So
line
yeah,
12. Yeah.
if
Yeah,
you look
that's
if you look at line 12 and then it says type C implements A, you can remove that implements A, and that technically solves it for now. But you can modify this example so that doesn't solve it, is my point. Like like on C it says type C implements A, you could just put type C and then remove the B, and then technically that looks like it solves it. But then if you can modify the example so it doesn't solve it, is my point. Like by putting type B in subgraph 2. Yeah, that's what it was. Okay, so both subgraph ones have B and C, but B only implements the specific field in question in subgraph 1, and C only gives it in subgraph 2. Then where does the field in question declared interface wise? I think that's what it is.
Yeah. So the issue is that there is sometimes when you work with interfaces, you have the problem that you are forced to implement things in GraphQL.
Yeah, that's right.
And while removing sort of implements A from line 12 is sort of a workaround, you do lose some type
Subgraphing
information and some validation, like local.
Oh
like,
yeah,
like-
sorry. Oh yeah, sorry. In the tallest case, you actually have to have implements A, and for some cases, if like you had that subgraph return A, and then it actually could implement C. So you're right, you can't just remove implements A. Sorry. Okay, no, this example still works. My bad. Okay, okay, that tracks.
Yeah.
Something else. Okay.
Yeah.
Yeah, and in this case, the name is, I think, perfectly matched, because like this is not implemented here; it's implemented somewhere else.
Yeah.
Yeah. Yeah. Okay.
Yeah. Yeah. The only thing is that yeah, but I wouldn't also like. It would make no sense to have a specific directive then for provides that basically has a similar functionality.
Yeah. And especially because it would also be a breaking change.
Yeah. I mean, the prior art argument is also valid here. Okay. So we close this issue and we don't do it. Okay, just had it in my notes, and that's why I thought we discussed it. Okay, there's the next into external. Pascal, do you want to go into it?
Yeah, I mean, we just discussed this. So if you could paste your case here as well,
Yeah.
I
will.
think that's so we said provides is something that we don't cover, but for provides we could rename it, but in this case we keep it and we can just keep it.
Okay.
Do we need to verify that this actually works? Multiple places. So you can say, can you do a list afterwards?
We'll type correct that later, just so it's not lost. Okay, so this external we have covered. Behavior inaccessible, inaccessible, and internal. Yeah, I know. So this is we also talked about this at some point. I just want to make sure that we are here all on one page. This is about when you set a type internal or inaccessible that is also used in unions, like this guy here. Then basically in the composition, we are removing this. So in this case, you would only have user, for instance, in this union. And I think this is mainly about what do we do error-wise. Like we could fail the composition, say that's an error to do that. So you cannot have a type inaccessible when it's used in a union because that will lead to runtime values or whatnot. We could have a composition warning and then basically return null at runtime, which could then cascade into null propagation. We could do a no composition error and return null at runtime. So there's no warning, it's just allowed. And we just also propagate null if it's non-nullable. Or there's no composition error and we throw an error at runtime if that type is here. I think what Darius noted here is option that he would prefer option E, composition warning plus runtime error, just one additional information here. What we said in general is that only warnings can be ignored. So if we make this an error, then the user, then the spec says you cannot disable that. So basically it would always, or it must be a composition error. Whereas a composition warning can be upgraded to an error or even downgraded to don't bother me with it.
Basically, when we talked to customers about this use case, in our case, we found they really did not like it propagating to abstract types. So they didn't want things that had, in this case, user in it to have to be declared inaccessible. And they said they would just guarantee their subgraphs would return it at runtime. And that should be an error if they did. So that's what Apollo landed on, at least feature-wise. But
is there any difference between example 1 and example 2? in our behavior? Because I think that's
Oh, I didn't see the you have to scroll down a little bit, sorry, to see. Maybe
Yeah,
sorry,
it's also enum values because that's also a closed
yeah.
set.
So
essentially.
enums are definitely something we only detect at runtime, I think.
yeah, yeah. If you declare unit value in
But the first example, is that also something like wouldn't we remove user from the union in that case?
That's right. That's right. And what I'm saying is, if user was declared inaccessible, we wouldn't have forced search result to also be declared inaccessible. We would just say search result is now just group. And if
Yeah.
the subgraph returned a user when it was supposed to get a search result, it would result in a runtime error.
Would you, 1 second, would you replace search result with group, or would search result just have group?
Search result will just have group
Okay,
as a.
great. Okay.
Yeah,
Yeah, and
I
it
mean,
might still have other
yes,
numbers in there.
that's what I wanted to say.
Yeah.
And if you would replace it and they would add more to it later, it would also break the API. But what about, like, should we put it as a warning so that the user can say it's even a composition error for me? Or should we
Yeah,
just ignore it?
there's an argument that if they have explicit guarantees that they need to make, that they probably need to be warned about them just to just be aware of them. I think maybe that's one thing. Like this isn't going to be guaranteed by like when this occurs in composition and we pass this through, we are sort of assuming that you're going to do this thing, and so it might be useful to maybe new users at least, or like if they're not aware of that system, to start knowing about that. That it's up to them to make sure they don't return it. But that's I don't know, it's a matter of
Yeah,
opinion.
because if we say this is a composition warning, then people could like either decide to say, okay, I want to upgrade it to an error, or I know what I'm doing and I ignore it.
Yeah, yeah. It definitely shouldn't be an error, I think, but the warning is probably fine here.
And
So I think
would you throw an error at runtime or just return null?
so in that case, we would actually take it as an error. Or it wouldn't be just be silently hidden. It would be
Yeah.
as if a subgraph had returned a completely unknown type to the router, basically.
Do you have a standardized error for it?
I think we specifically wanted to appear as though a subgraph returns something that it should be indistinguishable from the router not knowing about the type.
Yeah, I'm just asking, do we want to even tell the
We don't tell the user about the type if that's what you're asking. Like we don't tell them that, oh, we returned a type that you're not supposed to see. There's nothing like that being shown to like the clients.
yeah, but you are giving away that you basically are a gateway and whatever. If you say there's a subgraph error.
Yeah, in that case, you don't exactly know what I'm trying to remember the exact error messaging syntax there. I don't actually remember off the top of my head. I know we're actually going to change that a little bit, I think, at some point.
We could
So-
also just specify you have to throw an error and leave it up to the implementation.
Yeah, I think
Okay,
that's fine. The main thing is to not leak information about like what type specifically had been passed in. Like we don't want to, tell people, hey, be returned to user. Nothing like that. I think that's the only thing to note there. But yeah.
Just so I don't forget. So composition warning and runtime error. Okay. It's all those details.
Yep.
Yeah, it's what makes it break or work. Okay, this is we talked about it. Says file types. Ah, yes, this is from Darius. Given the following schema interface.
Also, at runtime, you can't be anything, I think is what he's getting at. Because, sorry, like interface A is implemented by I1 and I2 in different subgraphs, and so I think no, that's not it. Sorry, I don't know. Well, I was trying to see what it's getting at.
Let me scroll down. Maybe both examples above should result in satisfiability errors. Apollo test. Why? It's shareable.
Oh yeah, we do have code around this in satisfiability. Check.
Because of these, I don't have a way to transition. There's no lookup, right?
I2.
There's
Well,
no key. There's no key in Apollo, and there's no lookup in.
But do you need that?
you
you
never have to access
Here you
I1
have
and I2,
one
right?
I2 and I1, and because you have just one entry A, right? You go on the
Yeah.
interface A, and then you cannot safely transition for if you cast to if you have a fragment, for instance.
But wouldn't satisfiability catch that anyway? Like, why is this a special case?
I think that's just one case that satisfiability has to catch.
That could be.
The Apollo link test, can we look at the errors that are shown in those? That might also tell us explicitly like what the satisfiability is complaining about. The field is not intersecting times. You scroll down a little bit, it might show the error message. I forget whether they're inline for these tests because it might be ancient. Okay, here we go. So shared field query returns type A as non-intersecting set of possible runtime types. The runtime types are A and I1. Okay. Yeah.
But this is all shared
That's what it
field
is.
must resolve the same way in all subgraph. This is a validation rule, indeed, yes.
That's the one. Yeah. Okay. Now I remember. It's
But
yeah.
is this like does this make sense?
Like the point is like if you ask this field one thing in one subgraph, or if you have a choice basically of choosing where you resolve it, but the problem is with either choice, the set of possibilities of what you can have are
Yeah,
usually
but let's say
Because it return because the field has no arguments. Is that why? And
no,
depending on the query, you would get a different object.
it's not even necessarily about the arguments because they have to also be provided the same to both subgraphs, right? Like the query planner basically has a choice of choosing one subgraph or the other for a field. And the thing is, the contract is shareable is that it shouldn't matter which choice you pick. But if they
Yeah.
are
Yeah.
non-intersecting sets, then that means it has to matter.
And
Yeah,
are
that's-
the are
but-
the additional fields, the I1, I2 fields, even needed? Don't you have the same issue with just X?
Yeah, yeah. I think the I1 and I2 are just a distraction, maybe. I don't know. Like,
Yeah.
they're probably just more because when people implement an object type, they usually think of like it being different from the interface type it implements. So that's probably why there.
But is one second, is this path dependent? Because there is a use case where this would be completely valid. Let's say you have three services. You have the person service or you have the book service and you have the DVD service. One manages books, the other manages DVD. And then you have the index service, which knows the IDs of books and the other one, DVDs. And now, depending on what type you have, you go to different subgraphs.
Yeah, but the point here is that when you ask for A on the query route, you're asking for an interface. You don't really know what concrete
Well,
type.
That's exactly
Yeah, but there like I understand that for A, but let's say, for instance, this is node, and you have an ID as an argument in, and then you choose based on the fragment, based on the code, the most probable jump you do, and then even decide in runtime which subgraph to pursue.
I don't think we ever do that in query planning.
Wait,
I think we assume it has to be statically.
Yes, but what I mean is like what we do with nodes, for instance. We make this.
Yeah, no, that's an addition to the model we have today, like the ability to like
Yeah.
extract an ID and sort of know the runtime type based on the contents.
Yeah, my argument is this, like if we make it over general, it would close this possibility, right?
And the issue here essentially is Shareable has a certain contract that users have to agree to when they use it. And the contract here is that it shouldn't matter which subgraph you choose to resolve A in, it should result in the same result. And the problem is here it's impossible for that to happen. So that's why it's complaining.
Yeah.
But that's a satisfiability rule, right?
That is a satisfiability. It is implemented during satisfiability.
So it's
But
not a static schema validation rule. This would just end up in a satisfiability error.
Well, no, the current satisfiability, like if you look at the Apollo's current satisfiability algorithm, there has a specific section where it needs to do this validation, is what it is. Like it isn't in satisfiability, but it is in a specific section of satisfiability code. That's maybe not currently in spec code.
Yeah.
In the spec.
So I'm talking about 1 second. I have an example, and I want to ask if this would be a problem with this rule.
This, by the way, just what.
Yeah, it's the issue you're talking about, which is the node interface or like the types implementing the interface, but some fields are not resolvable or the types are missing. And then when you want to resolve the node ID, you need to like expand the type into like subtypes, like the type that implement the interface. And you could do like 2 calls to get the data, one to one subgraph based on the, you know, let's call it like a fragment, or like for this specific object, I get that. For this specific object, I go to different subgraph. And then you could potentially resolve it. Yeah. And all the gateways don't do it. I think like the only one that does it, but I'm not quite sure, is GraphBase. And the one that we are developing. So
should the node root field even be shareable here? Shouldn't you have a single entry point that would like decode the ID and then?
Yeah, but it's inefficient. Then you have to design a subgraph that is wholly responsible for this and has to know everything about these
yes.
IDs.
Well, I
It
mean,
would be
it does have to be a subgraph. I mean, it could be a feature of the gateway or the
Yeah,
router to
okay.
decode that. But what I mean is you don't actually want multiple node root fields in the different subgraphs, because that would
You shouldn't have to know about all
that would mean
possible.
that you have to sort of statically choose between them. So what you want
Yes,
is
yes.
another entry point. It shouldn't be shareable. That's what I'm saying.
Yeah.
There should still be a single entry point from a client perspective.
Yeah, this is how we do it basically. You annotate a lookup as a node lookup, and then we compose the node field on the gateway from it.
Yeah, so that wouldn't really result in the kind of composition error or satisfiability error that we were discussing with shareable, right?
Yeah. Yeah, you're right.
So the shareable is the trigger.
Yeah.
So Camille, is there a reason you've marked node shareable here? Is that needed for the kind of implementation you have in mind here?
So this schema is from one of our customers, not the same schema, but like the reproduction of the issue, let's say. And yeah, this is completely valid in the composition, or it passes the composition.
But are there multiple implementations of the node root field here? Or is the shareable basically meaningless?
So the shareable is
Yeah,
just like,
there's-
oh, I have like there's the subgraph A and subgraph B. And
These
the
two.
only difference here is the external annotation on the ID of the chat in one subgraph. And there's the external in the subgraph A.
Yeah,
on the
you don't
other...
have the problem
No,
because
yeah,
you have basically all types everywhere.
yeah,
Okay.
it's just the field that is external. So then you have to decide, and like the gateways, what they do is they don't create a plan. So it's not a composition. It's like a, not really like runtime error, but rather, you know, hey, we couldn't figure out this for you, which is okay, I guess. But there is a way to actually resolve the data, which is, I think you called it like type expansion or like explosion or whatever. basically you turn the interface into like actual fragments when you do the, let's say, normalize the query or like turn it into whatever format, right? It doesn't like it's an implementation detail. And then you resolve individual pieces. And by pieces, I mean object types, basically like fragments, right? Into subgraphs. So, hey, I want to resolve the, I don't know, account ID for that node in subgraph A and chat ID in subgraph B. So then you can like pull those data from those two subgraphs and then continue doing the whole thing, which is okay, but then it's like super expensive.
If node is the entry point, like are you actually sending these requests in parallel to multiple subgraphs? Is that
yeah, in parallel, yeah.
Okay.
I mean, that could be done. It's just like from the audit I did, that's really the only case where I'm not 100% sure, what is the correct answer.
And
here.
it breaks down quickly because it really assumes that like all types are implemented in all subgraphs.
Funnily enough, I talked to Matt from Facebook or from Meta, and he said actually like Facebook wouldn't specify node again. They would rather use something like lookup, like what we specified now, because this is a cleaner way. Like Node always has the problem for query planning and for a lot of other things because it's not specific enough. But it was the mechanism that they came up with at the time, and they are just stuck with because it's now in use, right?
Yeah.
But the case that we actually make with lookup is to have a semantic way to do the same thing and communicate the same thing to clients. Actually, I mean,
but that's only for the like the reload case, right? That Relay uses Node for. But you still have the need to sometimes, like you basically have an ID on an interface, and you have like a number of implementing types that could implement that interface, but they all share the same ID space, let's say. Like you still need to like even for the like the product example that we use a lot, like with the different like books and DVDs and whatever. If UPC is the ID, there are still cases where you would sort of like to know, based on that ID, what the implementing type is without going to all the different subgraphs and asking them whether there's a match.
But there are two different concerns, right?
Well, I mean that's one of the use cases of Node as well, and the other one, like it's just the ability to have an ID and to just like go to the graph and ask it like what implementing type it is. But I definitely can see how the reload use case, like being able to sort of refresh data on the client, like that's what Relay uses Node for, among other things. And that, like in that case, like lookup is a much better match because you already know the runtime type.
Yeah, and the like you don't need a fragment. You immediately have the semantic field.
Yeah.
And it also removes all the complexity on the backend side. Anyway. Okay. So do we cover that at the moment, Pascal, in the
I don't think we have a validation rule for this. Thanks. I don't think we have a validation rule for this one. And again, just for me to understand it fully, it's only when the interface field, the field with the interface is marked shareable, then every service using this interface has to provide, every service declaring the shareable field has to have the same interface implementations.
Well, they have to have. It has to be the case that like it can't be a zero size set of possible runtime types is what it is. So like every path when you try to like look across all the possible possibilities across the subgraphs, they can't resolve to just like nothing, because it means that like a shareable field was violated. I have to check the exact. I need to look at
You're saying this would be valid if type E1 would be declared in subgraph B?
type E, yeah, or sorry,
Yeah.
if one of I1 or I2 was declared in the other one, then this would be valid because
Oh,
the intersection set would have at least size 1, so it would be
right. So
possible.
it's about intersection. Okay.
Yeah, but
like
and then isn't the underlying issue that like if field A is shareable, that is like that assumes that the query planner can pick either one
that's right.
as an entry point. And in this case, because there's no further information, like you don't know what the implementing type is, that there wouldn't
That's
be a like you can't really pick between subgraph 1 and subgraph B.
Yeah, in
It-
in this case specifically, right? Because it also doesn't have any arguments, keys, or whatever.
But
Well, but arguments are never a reason for picking one over another
But-
in the current query
Yes.
planning model.
but is it really the intersection that has to be greater than 1? Because like you'd still not know about E2 in this case, right?
Right, so basically what putting shareable on that field would guarantee is that it would never return E2 then, if only one of them knows about it.
But it could still do it, right?
It could still do it, and technically it would still go through. This is like it would still technically work, but it would just mean that like you're probably using shareable wrong. Like this is more about an indication about whether you're using the shareable directive correctly, or this particular validation, if that makes sense. Because like shareable is supposed to mean that it shouldn't matter which direction you went, subgraph 1 or subgraph 2. And if they don't intersect to anything, well then it's guaranteed that they can't be doing the same thing.
Yeah, but the like the
But-
inverse isn't necessarily true.
Yeah,
Like
that's-
like it doesn't guarantee that they're doing the same thing at runtime if the intersection isn't. Yeah.
That's
I
right.
mean, we can continue. I think I have an example where it would be perfectly valid to do this. But let's continue. I will add it to the
Yeah, I
issue.
mean,
We only have 7
like
minutes. Okay.
even if we have an example to make it strict in the beginning, gives us option value to relax it when we have use case for it.
So when you have nested object types between two, when you have a shared type, a shared value object between different services, let's say you have something like details. So you have movies and you have books. Both have a field called details, which have an object type details, which exists in both graphs. And now you have different interface implementations of a field on this details. Then it would be perfectly valid because it's just a structural change that you have to organize your schema.
But details wouldn't be a root field, right? You'd be going through a specific type to get
Yes.
there.
Yes.
So you're already in a specific subgraph at that point.
Well,
Or at least there's you're in a specific path.
Yeah, so then it's even narrower, more narrow than this. Then it's really shareable.
Yeah, I mean there's no need for the query planner to pick one subgraph over another in that case, because by going through either books or DVDs or whatever, you've already decided sort of which subgraph is responsible for implementing that type.
Okay.
Yeah,
Right?
this
Are you understand
specifically
the
on
examples?
fields, yeah. Or it's specifically the shareable field that triggers. I'm looking at the code for the validation. The comments around it at least. It is specifically when there's a shareable field that occurs and that returns an abstract type, I think.
Okay, so we just need to make sure that we catch it in satisfiability, because that's not statically analyzable in an easy way.
Yeah.
You need the whole object tree. So that's
Yeah, you
again,
need the path.
yeah, so it's satisfiability. Okay.
Okay, I think we are at time.
There's a simple one.
Which
No.
one?
The external arguments, external error messages.
Which
Ah,
one
it's
is
not
that?
in there anymore. Ah, don't worry, it's not in there anymore.
Okay.
Did we
Well,
close?
that was quick.
Did we close this one? The one we looked at today about the validation rules, that field argument mismatch and external argument mismatch.
It could be, Pascal, that we
Because then
there are 4 that I didn't put on the discussion yet. We have 4 or 5 left. Could
For
be
next
one
time,
of
you
these.
mean?
Yeah, I mean, we have this list for next time still.
Yeah.
I mean, this one goes out, but the rest we have to discuss quickly.
it's great. We started with 44 issues, and now we have 44. So that's great. So
Yeah, I
yeah.
mean, it's not all gone, but important is to write the decision down we have on each of these issues.
Yeah, because
Then we work them off, but that could still take some time, right? But important is that we agree the direction. Awesome. I think with this we can end the meeting.
All right.
See you
Well,
next
see you
week.
next week.
Bye.
Bye bye.